then Goldwasser visited us. He is an assistant professor at Purdue University. He did his PhD at Urbana-Champaign and then postdoc at Maryland. And he works at the intersection of natural language processing and computational social sciences. So we'll hear more about his work.
Okay, thanks. Hi. So my name is Dan. Most of my work falls on the intersection of machine learning and specifically structured prediction, and more recently on computational social science. And today what I would like to argue is the importance of context when we're trying to understand language. A good example of that is this. So, should you stay, or knowing that this dog is sick? Should you stay or should you leave? So a lot of it depends on, well, if you can hear me say it, you can hear me say sick or sick, which would perhaps disambiguate it. But when you see it in text, these kind of cues are not there. So you need context to figure this out. Typically, when we think about context, we think about in the context in the context of NLP, we think about it as things like that. We have similar vocabulary that takes different meaning given the context in which it is written. For example, here are two reviews. One is positive, one is negative. Green is positive, red is negative. The interesting aspect is that they use a very, very similar vocabulary. So in the context of as a positive review, it was like, dude, I just watched this horror flick. The selling points are nightmare scenes, torture scenes, terrible monsters, and so on. A similar sentiment words would be when used in the context of buying popcorn or getting food, would actually indicate a very negative thing, right? So don't buy the popcorn, it was terrible, the monster selling it must have wanted to torture me, it was so bad it gave me nightmares, right? So the sentiment carrying words are the same, but given the fact that they mean like tortures are actually good in the context of horror movies, in the context of food you buy, not necessarily something you want to associate with. So in this case, you can think about contextualizing words and saying, well, these kinds of words in the context of food equals bad, while in the context of horror movies they can be considered good. And sort of the Sesame Street of NLP, the Berts and the Elmos and the Ernies, or contextualized word embeddings broadly, are very good at disambiguating such expressions. Right? So they identify that the word, let's say, nightmare, appeared in the context of a horror movie, and as a result it would represent it in a different way that captures the positive center, at least hopefully. However, this is not a magical solution, as both people who try to use it and recent work that try to look more closely at what these kinds of models learn, very often, because it's such an expressive representation, it latches on to simple heuristics that explain the data, rather than understanding the underlying phenomena. So this was shown by McCoy et al. In recent ACL, where they showed that they analyzed textual entailment and showed that the classifier learned by BERT and in general many other similar models just learns a set of simple heuristics that explain the data. But if you don't change the value of entailment, but change those heuristics, everything crashes. So this is not, like, BERT is not, I guess, not the final word. But even if it is, in many cases, we don't have that context. This context is not necessarily a linguistic context. For example, the difference between this is sick and this is sick is relevant for the same thing. Like I could say that this dog is sick, rejecting it, or is sick, and it's great. The linguistic expression would be identical. So how can I actually disambiguate it? Who is likely to say, this is sick? Doctor. Well, no, this is like just the opposite, right? So people under the age of 18 or, I don't know, undergrads at most, use that slang term to mean something positive, right? After that, you tend to only use sick in its intended meaning. So in this case, the demographic property of age actually can help us, the age of the speaker, can help us disambiguate the linguistic expression. The main problem is that it starts to get hard to designate demographic properties for every property, for every ambiguous word or ambiguous sentence that you have. So you want to find a way to generalize over that. A nice example of that is the gun control debate that's currently happening, where the phrase thoughts and prayers, originally used to refer to a sense of solidarity with the victims of mass shootings and their families, have now been sort of reappropriated to criticize Congress for lack of actions to prevent future mass shootings. So there is a use of thoughts and prayer that is used ironically to indicate thoughts and prayers are not enough. In this case, understanding the political context of the speaker helps to disambiguate it. So in this case, we have the sort of the hipster giraffe indicating like the left side, and the conservative cutie pig to indicate the right-hand side. And if you had information about the company that the speaker keeps, he'll be able to say, well, it looks like they meant a sense of solidarity rather than criticism in this context. Okay? And throughout my talk, and in general, my work, the work that I'm pursuing, tries to come up with a generalized way to capture this intuition. All right, so in many cases the text alone is not sufficient. It's not really surprising because we have a shared context and we all refer to it. This context could be a physical context, but it could also be a social context where everybody is on the same page, so these things do not need to be said. So the problem of contextualized text understanding could be defined as creating a text interpretation that's coherent both with the content of the text, but also its author and the social properties of the author, and all the other relationships that they keep. This often results in, instead of a single document, results in a single sentence in a complicated information map. In the context of a single document, and you can think about converting just the text into a document graph by explicitly representing entities and their activities and so on. And we originally did some work in this direction to try to model satirical versus real news. And more recently, we worked in the multi-document settings where we have an information landscape that we're trying to characterize. For example, we have many news articles and we want to identify bias. We have many legislation, many bills that have to be voted on, and we want to understand who's going to vote for them and on what grounds. We have forum discussion, tweets. All of these are many documents that we need to find some consistency when we're analyzing them. So the main technical question is, how do we recover and use this context? Unfortunately, it's not always observed. Like it's not the case that someone just tells us, oh, well, like, look, I have those friends, and those friends influence me in this way, and as a result, I'm saying this. However, on the other hand, there's often this, what I call a trail of clues that the context leaves behind it in the form of social information, relationships that we can mine from social media, and so on. And we want to leverage that. So when we try to approach it, we try to find a consistent way for representing and reasoning about content and context together. And that actually sort of corresponds back to the technical solution, where when I talk about representation, I'm going to talk about ways to embed the context and reasoning to make inferences on top of this representation. We're going to think about the context as a set of latent variables that we need to recover, their values as part of predicting whatever outcome we care about. And instead of thinking about end-to-end classification, as is usually done in the context of deep learning, we're going to think about it more like characterizing inference procedures or inference processes, the atomic part of which can be learned from data. However, we do have an explicit symbolic representation that tells us what kind of decisions need to be consistent, or at least encouraged to be consistent. I'll talk about three applications that we worked on. The first one is political discourse analysis of Twitter. The second one is political perspective in news article, and finally, open domain stance prediction, which sort of both are different applications, but they also span the technical space in different ways. In the first one, the focus is only on inference. The second one is more on deep representation. And finally, we try to combine the two. The repeating theme in all of them is how can we leverage the context information that we have such that we can improve performance and, more importantly, reduce the amount of supervision that we need. Right? And the question, what we'll usually try to show, that we can replace direct label with context. It constrains the learning problem so much that we do not need so many labels. All right. In general, if you have any questions or comments, feel free to. All right. So I'll try to give sort of like a general idea of the technical approach that we're using. It's somewhat idealized in the sense that I'm hiding many details, but it's also not that far off from what we're actually doing. It's just a little bit more abstract. The first part, which is the symbolic part, is grounded in the literature of graphical models, and we have a declarative language for representing it. So we can think about the elements in this inference process as little decisions. It could be, simple classifiers. In the graphical model language, we indicate this factor graph, a node is a decision, and that little box at the bottom represents the scoring function used to score predictions. We can look at the dependency between multiple decisions by adding other nodes to the factor graph and putting an edge between them. In this case, we can score multiple decisions together and capture their inference. A very, very simple example is dependency between consecutive part of speech tags. We don't deal with part of speech, so if we want to think about this, you could say that if we have two politicians and I want to know their stance on a certain topic, I can model the agreement between them by adding this high-order potential that forces consistency if they agree. In many other cases, we could have latent variables. These are variables that we know shape the decision or shape the context of the decision. However, they're not directly observable to us, and we want to make some reasonable guess about their values. For example, we could say that a good indication of what a certain politician would think about an issue would be how they frame their thoughts on social media. We might not have direct knowledge of that because they're not saying, oh, I chose to frame this issue in this way, but rather we can make inferences about that and represent them as latent variable, which are both associated with the scoring function and are connected to the output that you want to predict. Those latent variables could be structured. For example, if I'm going to say that there is a strong dependency between how a certain politician will frame their thoughts on gun control and, let's say, immigration. This is captured by the factors connecting multiple latent variables. In this way, we are shaping the latent space in a way that is consistent with our knowledge of what type of topics tend to correlate. Finally, we can connect all of those to the output signal, and we get a way to characterize the context over the output space. Okay? This is a very, very general framework. It helps us to capture social behavior, for example, by forcing agreement between politicians that act in the same way over unobserved framing or other kind of lexical information in a unified framework. We originally worked on this to characterize satirical expression. For example, our latent information was what kind of entity type is identified in the text, and then we combined that with a latent variable for entity behavior. We wanted to see if the two of them match or they don't. Right? So it's satirical context, they usually don't. All right, so it's often easier to think about these structures in a declarative way, which allows us to communicate these models to humans and potentially also get humans to communicate with us and build these rules for us rather than label examples. So instead of working with factors, we're going to work with entities, relations, and probabilistic prediction rules. For example, if I have two documents that I know agree on the topic, and I know that the label of the first one is positive, then the label of the second one has to be positive as well. So this is an example of a higher order potential that we've seen before, now expressed as a logical formula. Right? And in general, you can characterize complex decisions, complex factor graphs as a collection of these rules, with having the advantage of, you can sort of look at it and understand what it means. Given data, these rules are grounded, and we create grounding factor maps. So in this case, we can have rules capturing single decisions, like we have some property of a variable, property of an entity, and we build a classifier around it. Or we can have higher order potential, looking at combinations of multiple decisions together. The end decision is an inference process in which we look for the highest scoring assignment. Just to demystify the symbols a little bit, psi here corresponds to assignments to the relations in the rule. So essentially, it's an indicator function saying if the rule is active or not. Am I using this inference rule in my decision? And WR is the weight that I associate positive applications of this rule. And this is learned from data. Okay? We will revisit this definition in a second. So up until now, I defined a pretty standard way of capturing context by defining essentially a templating language that can be compiled into a graphical model. However, the year is not 2011, and neural networks have made a reappearance. And in fact, there is a natural way to capture context, right? We can think about context, capturing context as essentially embedding graphs or relevant data structures. Right? So instead of saying, well, I have this network of politicians that have to agree and disagree and so on, and I want to reason about their agreement patterns, I can just represent them in a high order space, in a high dimensional space, and say, well, if their embedding is closed, they agree. Right? So that would be the alternative way of doing it. This is a diagram that I stole from the Graph Convolution Network paper, which is a famous, or currently famous way, maybe by next year it won't be, way of embedding graphs using graph architectures. There are also other simpler ways that look at local representations. But essentially they do the same thing. They take graph nodes and convert them into a higher order representation. As my general philosophy in life is, why choose if you can have both? So one of the things that we are currently working on is developing a declarative framework in which we can define models using this declarative language that characterizes the factor graph. So in that sense, it uses rules as a context. But on the other hand, it also uses representation as a context by defining neural potentials and relational embedding. Just sort of close the loop we've seen before. So this is the decision function, the inference decision function. We have a symbolic part corresponding to the rule and rule activation over symbols, which we can force consistency by adding a set of constraints. For example, if two users agree that their labels have to be similar. And then we also have the neural part where we define the scoring function for these potential activations using neural networks, but even more interesting than that, the underlying representations for these neural networks are relational embedding. So we characterize the embedding space such that entities have to be consistent across all the rules that they participate in. Right? Which is a property that allows us to do fun things, like, for example, push information. Like we have information about entity of type 1, user, which is connected through a graph to entity of type 2, let's say document, and push information from properties that we know about the user label back to the document. Right? So the labels can propagate over both the representation using the relational embeddings, or over the rules, which are over the outputs defined by the rules. In case it wasn't clear, it will be in the next couple of slides. All right, so I'm going to start talking about applications a little bit. So the first one is decoding political messaging on Twitter. Anybody understands this reference? I should get rid of it. Nobody ever gets it. Song from the 60s. Never mind. All right, so politicians are all over social media this way, specifically Twitter. When we started working on it, it was very recent. Now it's not so recent anymore. Unlike traditional outlets, this is a conversation in the sense that politicians put their content out there. They look at what responses they get. It's a way to float ideas, check the responses. actively target influential users that would push their information further, and so on. Right? So it's a very active environment, which is both a good thing and a bad thing. It's a good thing because, cool data. It's a bad thing because it's highly dynamic and constantly changing, meaning that it's kind of a moving target if you want to work in supervised settings, right? Because there's new terms that keep being added. The hashtags of yesterday are not the hashtags of today, and so on. So we constantly need to adapt. We want to automatically understand this data, which we thought along several dimensions. The first one was to work on identifying stance based on Twitter content, which I will not talk about because, for the interest of time. And the other thing, which I think is more interesting, is understanding the tactics that politicians use when they frame their message and want to get support. So the first one, let's look at this example. 6 years later, healthcare costs have skyrocketed and millions have lost access to their doctors. Hashtag repeal Obamacare. In this case, the stance is not a challenge. However, if you want to, you can think about an explanation for this stance, which is saying, well, this person is framing the issue of Obamacare or healthcare, the Affordable Healthcare Act, as an economic issue. And since the label is negative, the sentiment is negative, what essentially they're saying, it's too expensive. So we can think about framing as a more abstract sense of identifying what is the reason for the stance that you're holding, right? Because, if you have to develop a specific set of reasons for every policy issue, you're back in this moving target scenario where it's really, really hard to keep up. These framing dimensions are constant for all issues. They do have different vocabulary depending on the issue, but the label at least is the same, and it allows us to analyze all issues. Okay, so framing is a strategy for biasing the discussion of a specific issue. You can talk about raising the minimum wage, for example, using the economic frame, talking about the costs or benefits or harm to the economy, or the quality of life in terms of, well, it would allow people to have better lives. It's clear that depending on how you frame it, you're sort of priming the discussion in the direction of your own stance. Right? And this is really how politicians try to control the agenda, or the direction in which the conversation goes. From a technical perspective, this is a 17-class classification problem corresponding to different claims. It's a multi-label problem, so more than a single one can be applied. And we looked at settings in which we have both fully supervised and in cases where no supervision was available. Another case is we looked at moral foundations. To motivate that, take a look at this. Both of these are responses by prominent politicians to mass shooting events. One of them is from the left, one of them is from the right. One of them supports gun reform, the other one does not. Can you tell which is it? And it's not in the text, so can you tell which is which?
I heard the top one was Republican or conservative.
Why do you think that?
Prayers?
That's right.
I'll go for the our prayers.
Okay.
They're indexing into religiousness.
Okay, so reference to religion. Okay.
I'd say at the bottom one with another seems to be really implying that this is a problem that no one's addressing.
Yeah.
So that there is some way that this should have been addressed, and it's not. Another.
Okay.
I think like the top one lacks the reference of shooting or guns at all, which is weird given that we're talking about a mass shooting event. So I would guess that's also an indication that it's a Republican tweet.
Right, so
I'd say the top is Obama and the bottom is Trump.
I'm not that sophisticated. I actually don't
words.
remember. I think the top is Paul Ryan and the bottom I think is Bernie Sanders. But I'm not sure about Bernie. I think the top one is so it's easy, pretty easy. Like, there's no stance here, right? Like they don't say I don't support, don't touch my guns or touch their guns. But it's still pretty easy for us to tell. And one of the things that we notice is that there are these repeating dimensions that allows us to tell it. And this corresponds to moral foundation. So one of the things that stood out for us is that in the first one, there's all these expressions of unity, solidarity, our, us, a lot of us language, emphasizing loyalty to the group and the coherence of the group and the strong connected structure, which is one moral foundation, protect the group, loyalty. The other one talks about, this is a very visceral language. There are the horrors, there are this horrific thing that keeps happening, which is another moral foundation that has to do with visceral reactions, like purity. Analyzing content based on these dimensions allow us to identify stance, even if it's not directly evident from the tweets. Right? And it's another, you can think about it as moral framing. This work came originally from work on social psychology, specific from Jonathan Haidt, that became pretty famous for this work. They view human morality as a sort of evolutionary process designed to ensure the survival of the species. So each one of them has originally some evolutionary motivation to sort of leverage the fact that we are social creatures to help us survive. Each one of them has a positive and a negative polarity, so positive polarity gets praised for observing that moral foundation, and judgment, negative judgment on the other case, so care versus harm, fairness versus cheating, loyalty, authority, and purity. And there is a lot of work in social sciences aligning these kinds of judgments with other behaviors. For example, conservatives tend to emphasize more loyalty and authority and care. Liberals emphasize care and fairness a lot more. Religious people tend to focus more on purity. Right? Surprisingly, anti-vaxxers, also purity. Yeah. So just thought it was kind of an interesting point. Okay, so in this case we have 10 class classification, 10 label classification. In all of these cases, this is work that was done with Kristen Johnson. And we used PSL, which is just the graphical model without the neural architectures. We compared no supervision at all, only using simple indicators with full supervision. However, simple indicators were put in the context of a global reasoning process trained using the EM algorithm. The connected structure here combined linguistic indicators, social indicators, and behavioral indicators, where the last two identified agreement patterns between politicians. Right? I'm not going to describe the whole model because time, but I'll give a quick overview of the main things. So these are the type of things that we did in the context of identifying stances. So given the content of the tweet, we could try to predict the label if it's positive or negative. We looked at indicators such as sentiment, some keywords that are related to the topic, some identification of keywords corresponding to frame, and so on. Right? So that just resulted in a sort of a simple decision. This decision, in the case of stance, was at the level of the author of the tweet, not individual tweets. When we talked about frames, then it's individual tweets. We then looked at temporal activity patterns, and the idea here is that people who tweet at the same time, specifically when something interesting is going on in the world, means that they care about the same agenda. People who care about the same agenda and are also from the same party are extremely likely to agree. Right? It's very often the case that not all people in the same party are on board on the same issue or frame it in the same way, but if you are active around the same time, it's more likely that you would have some agreement. In this case, we align temporal distribution of activity, specifically around interesting events. Similarly, we looked at social relationships such as retweeting and following between different members of the house. In this case, we could say something like if person A retweets person B a lot, and person A uses a specific frame on a given topic, then the same frame would be repeated by the other person, for which we have evidence that they agree. Right? The actual rules were slightly more complicated because they constrained the space a little bit more, so we typically combined multiple indicators of agreement. Right? So it's like they retweet and they're from the same party, and so on. The trick to getting these things to work, especially when you don't have explicit supervision, is a lot of patience and a lot of sort of common sense of what kind of things actually help constrain each other. In terms of the results, clearly this is self-explanatory. All right, so the number here at the bottom is just, if we take the weak heuristics and just use them directly, we are at about 37. Again, this is a 17 label classification problem. The random guess here is really, really low. We start building increasingly complex models where we keep adding more information, such as temporal information, agreement information, social information, and so on, up until we get to 58.6, which is the best result without direct supervision. When we applied the same model using labels, we got a supervised skyline of 77.8, 79. Right? So we're not performing at the same level, but we can get meaningful results to allow us to analyze data on a large scale, even if we don't have supervision. So we did exactly that, and we looked at, again, like I'll talk about a couple of things that stood out. So we looked at understanding how members of the House frame the healthcare debate. In this case, we looked at the frame used by Republicans and Democrats separately. Some of them are not very surprising. They talk a lot about the economic frame, they argue about the cost. In this case, using the same frame does not indicate agreement on the issue. However, when Democrats talked about it, two frames stood out, the fairness and equality frame and the factual frame, which talks about figures and facts, which is unique to or overwhelmingly characteristic of Democrats and almost no Republican use it. Interestingly, the only Republicans that did use these kinds of frame in a distinctive way are the ones that voted on Obamacare. Right? So the aisle-crossing Republicans are the ones that actually framed the problem in a similar way to Democrats. And so that's actually kind of cool because it shows that there is some predictive power to this analysis in terms of how people will vote and their activity patterns. Another thing that we did is to look at how shooting events are framed the response to shooting events is framed by Democrats and Republicans. In this case, we looked at an analysis over time. So there is the point where the shooting occurs, and then over time, the discussion kind of dies down. One of the interesting things that we noticed is that both Democrats and Republicans use the sort of thoughts and prayers frame. However, the security and safety frame is really as high with Democrats as thoughts and prayers, but for Republicans, it's pretty low. A day later, it's high on both of them. So Republicans started talking about safety and security 24 hours later. Anyone wants to guess why that happens?
In reaction to Democrats? So they say the Democratic proposal to introduce Legislation X is a terrible idea, it won't help or something.
So this is actually the point where having interaction with social scientists is useful. Like frames do not constrain it enough for me to give a definite answer, but this is one hypothesis. So one hypothesis is that Democrats set the agenda and now the Republicans are following them and they're trying to negate the effect of not make the message resonate too much. Another one, which is specific to the San Bernardino shooting, Republicans framed the shooter as a terrorist, which allowed them to talk about safety and security, but in the context of security from terror attacks, not from safety from guns. And so it's a good question which one of them explains this behavior, and for that, we actually need to look at the data. One of the things that we're working on now is to expand the representation of frames to capture these distinctions, such that disagreements in stance would be reflected also in the frame analysis. So we want to break down the frame analysis into finer grained units. Okay, moral foundation, we basically, essentially a very similar story. We compared, animation went wrong, okay. We compared supervised versus unsupervised approaches. In this case, 81.6 is our skyline, 64.7 is our best unsupervised system. And again, we have this nice trajectory of improvement as we add more and more information into the model. Another thing that we thought was interesting, there is a lot of work on finding correlation between moral foundation usage and political applications and ideology. We tried to look at that in a very straightforward setting. So we said, okay, so if we were to look at the moral foundation dictionary is a dictionary that was released by Jonathan Haidt and collaborators that defined a set of words for each one of the moral foundations. So option number one, look at the tweets that politicians author, use them as features, and then try to predict where they stand. Another option, which is the skyline, is look at the actual identified moral foundation and use those as features. The one in between is use our prediction as features. And it's really those sort of telling things. So the data is balanced, meaning that if we use the moral foundation dictionary, we're basically at random. Right? So it didn't disambiguate ideology at all. The skylines of using the gold annotation is actually meaningful. It sort of strongly correlates with ideology at around 70%. In our prediction, we are at 61 for Republican and almost 67 for Democrats, which is sort of a middle ground between the two. The main reason that I'm saying that is I think this is something that tends to happen quite a bit, where we use resources developed by social scientists, which don't scale well or don't adapt to new linguistic usage. Right? So when we move to Twitter, everything breaks, right? Which is the case here. So that's a broader point. The second thing that I'm going to talk about, currently quickly because I don't have much time, is understanding perspective in the news media. So all news articles have a bias. It's not necessarily a bad thing, but we want to at least be able to capture it such that we are able to prevent information echo chambers. Unfortunately, this is not an easy problem. So if you look at these two, they are both of them talk about exactly the same event, the partial government shutdown from about a year ago. Both of them talk about the specific sub-event of that, which is Senator Warner criticizing President Trump for his inability to end the shutdown. However, the one that was taken from Breitbart News is a little characterizing it in a different way. Here, the sort of centrist one is just describing the fact that Senator Warner criticized President Trump for his inability to end the partial shutdown. Here, they're focusing on the fact that that senator was actually attacked for attacking. Right? So the vocabulary is almost identical and the facts are very similar, but the emphasis is different. Capturing this at scale for many different events is really, really hard. Right? Like all of these documents are going to have a very, very high overlap. Finding a good way to separate the two is going to be hard. But our key insight in this work was the only thing which is going to stay consistent in these settings is that there are two competing narratives. People who prefer one narrative on top of the other will keep preferring that narrative. Right? So if I prefer to take President Trump's point of view, or a point of view that's favorable for President Trump in this case, it's likely that I would keep doing that, and the vice versa. So if we have a way to represent what kind of people and what kind of attitudes people who share and engage with different types of contexts have, then we can make a much better prediction. And that's exactly what we tried to do. We created an information graph in which we had about 10,000 documents annotated for the bias of the author. We had a small number of users that are politically affiliated, about 100 politically affiliated users. So these are people like prominent members of the House, the GOP, the Democratic Party, the NRA, and so on. And we looked at following links between those politically affiliated users and users who share the documents on Twitter, right? That their tweets have a URL to those documents. This results in this complicated graph, where we have the blue and the red are politically affiliated users, the green are sharing users, and as usual, we assume that we don't have supervision. So it's really a question of whether we can push information about the label from political users that have the has label relation to users that follow them to documents that they share. Just to ruin the surprise, if you do it in a straightforward way of just counting the number of paths from the document to politically affiliated users, you do better than random, or better than majority vote, not much better. So majority vote was about 40 F-score, this was 45. Right, so that's that's clearly not, that's below the bar. So going back to our sort of neural symbolic approach, what we're going to do now is the symbolic part is going to be to force consistency across multiple views. The view connecting a political affiliation with users who share content, the representation of the document as a graph node, and then the representation of the document as text. Each one of them has some uncertainty about the label that you associate with it, and they have to be consistent. And in the neural part, we're going to define a relational embedding that allows us to propagate information in the embedding space from politically affiliated users to sharing users down to the documents. We use the GCN approach for that, which I will not talk about. But essentially what it results in is a graph embedding in which we have a representation for the labels coming from the sources, pushed down to the sharing users, and then we have an additional objective that aligns the representation of graph nodes with the representation of the text. So the two have to be consistent. Right? So we have a text representation that borrows parameters from the social settings. Right? So the text can help you predict what kind of people will share content similar to you. All right, so we compared several models. So in blue, we have the results of our no supervision model. So we're at around 72. If we just build a straightforward text classifier, we're at 74.6. So in this case, actually having a social representation is almost as good as having labels. Right? Like it's really a strong representation. If we have labels on top of the document, we almost completely disambiguate it. We're at 91. The difference between the numbers, we have different splits of the data. So we have random choice separated by event or separated by years to make it a little bit more difficult. It wasn't too meaningful in the end. We also tried to reduce supervision, reduce the number of links, the social links at test time, up to the point where we only keep 10% of the links. In this case, we still got a nice improvement. So this method is pretty robust, even when the data is extremely sparse. All right, I'll sort of finish with the final application, which I think is really cool. Typically, when we think about understanding content on social media, we think about it as slapping a label of, pro-life or pro-choice, Republican or Democrat. But in many cases, like life is more nuanced than that. Like when I'm thinking about a topic like, gun control, I want to somehow find a balance between not infringing on constitutional rights while ensuring safety for school. Right? That might be my priorities. So there are nuanced ways in which we can frame that policy question, and we want to align text with those nuanced questions rather than just an atomic label of pro this or pro that. In this case, we have a complex debate network consisting of the nuanced label, a nuanced claim in the debate. For example, limiting gun sale is unconstitutional. We have text nodes that correspond, that sort of relate to that way of phrasing the question. And our basic question is, are the two supportive or not? So it's a form of a text inference problem. But then in addition to that, we have information about the authors that write this text, and as a result, support or not support the debate claim. These people, those debates have people that read them. People have too much time on the internet, and they get to vote on who is convincing, who they agree with. Right? So in a way, you have this very strongly connected networks of opinions. Right? So I can define the problem directly over the claim and the document, over the users who respond to the claims based on their representations. And I can also say, well, if voting users agree with the claim and they vote for this person, then their stance should be the same. Right? So I can constrain it as a user-to-user representation, a user-to-text representation, and so on. Right? So it gives me a very rich structure to work with. We had about 21,000 debates to work with, resulting in 162,000 posts. So that's like more data than we're used to for these kind of inference problems, but it was okay. Computationally, it was okay. We had, in this case, 3 inference problems that we worked with: the textual inference, authors and text, and then finally authors and other users, who they vote for. And again, we used our relational structure, so we trained relational embedding that captures properties of users and properties of the text and aligned them. And then the objective that was used to train them was to say, well, what kind of users agree with each other, what kind of users agree with text that they authored and debate claims that they agree with, and so on, resulting in a shared representation for text, people, and debate claims. The symbolic side of that is that we forced agreement across all of these representations. So in this example, we can say that we know 2 debating users have opposing stances. The decision that we make about the user has to be consistent with the decision that we make about the text that they author. Voting decisions have to be consistent with the author decisions, and so on. From the relational side, you can see that our entity embeddings all share information from all the instances of the prediction rules. So the one in the middle is the embedding of the debate claim, forcing the debate claim, which is a textual entity, to be consistent with the representations of all other entities that agree with it, and all texts that agree with it. Right? So we're able to locate that claim, for example, on a political spectrum, by looking at properties of users that agree with it. If they are centrist, then this is a centrist claim. The embedding space will represent it, which is kind of a nice way to move between representations. A couple of things about the evaluation. So we looked at a couple of settings. In this setting, we looked at performance of several systems. The green one is just a text classification. This is text classification with a single constraint of author consistency. So the decisions of authors and decisions of the text that they authored have to be consistent. The blue line is everything has to be consistent, and the orange line is everything has to be consistent while sharing information at the representation. So the orange line is our neural symbolic model. In this point, we have no supervision at all for text. We do have for social representations, for social prediction, but not for text. Not surprisingly, text-based models don't do anything here. However, you can see that if you force agreement between text and user representation, which is basically what Graphical's model do, you jump from basically random to about 56. And then again, if you force agreement, if you represent that agreement in a relational space, the model improves to about 60. Right? And this is without any text supervision. Right? So there's a nice signal. This signal is consistent as we add more and more data to the text models. Right? So that gap is preserved as we add more and more data.
That dot line?
Right, so that dot line is, we take TriDNR, which is just a graph embedding model, and we train it on all the data, and that's just how it got. It does very good. This is essentially just a representation without inference. Another thing that we did is to evaluate the representation that was learned was to try to evaluate whether the text borrows properties from users who share it and author it. So the way that we did it, we looked at the language embedding that we got after training the model. We didn't do anything special. It was just a byproduct of the model forcing agreement at learning time between authors and the text that they have. And then we clustered the text the text of claims based on the new language embeddings. And we got two clusters. The color represents liberal versus conservative, and then how dark it is, how strongly conservative or strongly liberal or centrist you are. This is based on self-reported information from user profiles. So you have one cluster, which is the conservative cluster. If you look just at the strongly conservative and conservative, ignore the mildly one, you can see that there is a very strong distinction between the two clusters, between Democrats and Republicans. And again, this is just properties of language that were pushed to the relational embedding space. We did the same process also with sort of the basic word-to-vec embeddings, and there it was basically random. The effect was very mild. It was almost random. And again, this is kind of cool because this is it's not the post that people write, it's the claims that the debate is about. It's how you frame the discussion. So the embedding space represent what kind of claims, what kind of framing decisions correspond to Republican versus Democrat point of view. Okay? So this kind of thing. A couple of quick thoughts to summarize. So the main message here is that we want to build a joint neural symbolic framework that allows us to represent context in many ways, in several ways, both as a distributed and a symbolic representation. One of the things, why is it stuck? Okay. One of the things that we are working on is to include a lot more judgments about language and language structure into this framework. The nice thing about the framework is it allows us to sort of very naturally integrate other judgments about the same text, and they'll be represented both at inference time and at the way that we represent language. For example, we can capture conversational dynamics, such as the discussion escalating or not, or framing decision, into the way we represent the post, and as a result, make better classifications. So having a better representation for that is something that we're actively looking at. Another thing that we think is a very good machine learning problem is that right now we have this dichotomy between end-to-end learning and decomposed representation using graphical models. And this is one way of trying to combine the two, but you still have to pay the computational cost of running inference. The main advantage of a neural model is that it's just a forward, at least at inference time, it's just forward propagation of information that you can think about it essentially as greedy inference. Like everyone who works in the sort of structured domains knows that a lot of the time you don't need inference. You need inference to resolve serious ambiguities. So I think there is a good structure learning problem of learning what elements of the model, what kind of decisions can be represented in a continuous end-to-end way, and what we actually have to make inferences about. This would speed up things a lot. Finally, one of the things we try to do here is to align social and textual representations, which I think is a very cool direction. Like the two sort of compensate for one another, and it allows us to push information from one representation to the other, reduce supervision, and many other good things happen as a result. And I'm a strong believer in this direction. Finally, the real work was actually not done by me, it was done by my students. So many thanks to Kristen, who is now at Michigan State, Cheng, Maria, Xiao, Shamek, and Ita, who actually did very good.
code model, how do you construct the connections between latent variables?
So latent variables is a somewhat of a loaded term these days. So when I say latent variables in a graphical learner, I mean the discrete ones, not the continuous latent space. Okay? There's a factor graph. I define the dependencies using a scoring function associated with the potential, such that every assignment to the latent variables and to the output variables gets scored together. Right? Like I define it as part of the rules, and they're compiled into factors. The idea is that you can update those scoring functions by looking at latent inferences over latent information that support the final decision. Right? So the loss function looks at both the observed, like the predicted, and the latent variables. And it's sort of propagating the loss. Yeah.
Any questions?
So you add all these like the rules to help in the inference. You also, if I remember correctly, at the beginning of the talk, there's like using supervised data to predict stance, training stance. So I'm just wondering, have you looked at just use supervised data to go backwards to see whether the kind of rules you defined at the beginning are actually consistent, or actually identify some more new rules or something like that?
Yes, that's one of the things that I'm really interested in, because you could try to say, well, it's essentially like a little proof sequence, right? Like that. Do activation, explain the prediction. We tried to do it. Our original work in this space was on identifying satirical article and like sort of identifying specific activities of entities as being satirical or being sort of normative. And there we actually tried to say, okay, so these are rule activation sequences that we can try to say, are they good or are they bad, or do they explain prediction or not? Right now we're trying to find students to work on the problem of structure prediction, of like automatically learning the structure of the inference rule, of the sort of the inference program. And I think it's a good problem.
So going back to the moral foundation stuff, I like that idea of framing, or thinking about like issue framing along the lines of moral foundation. But I'm wondering like how complete is moral framing? So think about Boyston's issue general framing, like another thing from social science, because moral framing doesn't like capture things like cultural identity or like collective group or the economy, and those things seem to come up in political stance. So I'm wondering where you see those.
So, there's a lot of connections between the two.
Yeah.
A lot of the framing decisions actually correspond to moral foundations, but in a somewhat different way.
Mm-hmm.
For example, if you talk about cultural aspect, which is some of the Boydson frames,
yeah.
A lot of time those would correspond to in-group loyalty in the moral foundation, right? Because cultural, in the political spectrum at least,
yeah.
It's about maintaining our values as America, or things like that, and those are exactly what you see in moral foundations. And so there are some distinctions in which, the difference gets lost. For example, care and harm encapsulate both safety, security, and crime, which are three different frames in the Boydston definition.
Yeah.
So it's somewhat the same. It's more abstract. I think it captures a sense of identity of the speaker better than the Boydston ones. But then again, when you talk about policy issues, I think if you want to have an intellectual debate about policy, Boydston frames are better.
Okay.
In the sort of like very emotional space, political space, I think moral foundations are very better.
Other questions?
So for the relational rules that you use in the symbolic part, are they all manually written, or do you search over the possible space?
So right now when we're writing the rules, we write them manually. They define the dependencies between predictions. And like one of the things that we're thinking about now is how to automatically learn them. Historically, this is a structure that we want to learn the structure of a Bayesian network or something like that, and use something like BAC to define a search procedure over the space. the problem that once you start working on connections between neural methods and graphical models, everything starts to become painfully slow. So just brute force search is not computationally feasible right now.
Quick one. Who is now responsible for defining those rules?
In general, or
No, I mean,
as a
are you
methodology,
doing like
or practically who works on what?
you and your research team, or you have like political experts who are working on this?
So right now it's basically we try to think about what kind of dependencies are meaningful, and then we add them. A lot of the time, just by thinking about the data, you find them. For example, in the debate settings, it's sort of natural to say, well, users should agree with the text that they author, right? So the text reflects the belief system of the author, right? So the two should be consistent.
Yeah. I'm wondering if any domain knowledge would give you more.
Yeah, so it's easier to say like, well, if you frame the abortion debate as pro-life, then you're concerned, right? So
Yeah.
that's world knowledge, right? I can just write it down as a rule and encourage the model to make this prediction. And so it's a very general framework. If you have knowledge, you can just write it.
Alright, thank